Thanks all for taking part today. So I will be covering the topic of Helm today, and let's see what functionality does Helm provide, what that tool is, and in which environment it is used for, and what particular problems that it solves, and what benefits it provides us. So we'll be covering first a little background on Kubernetes, because Helm is a tool that is used on top of Kubernetes to make our lives easier when dealing with Kubernetes. And we'll cover the problem that the tool is supposed to solve, and the benefits that it gives us. We'll go over the Helm architecture as well, and some key concepts. And we'll have a look at how to create Helm charts. And then we'll finally get how to deploy Helm charts that we've created. So to cover to introduce Helm, like any other package manager that you would see, for example, with Debian or Ubuntu, you would find you would use apt. You can install any package hosted on any repository simply by running a command and finding it and simply running a command. And the same as for Node. The same as npm is for Node. So just like those package managers, Helm can reuse existing artifacts. In the context of Helm, it's called charts. But I guess in the context of these other package managers, they will be called packages. So you could think of a chart as a pre-built artifact that you can simply, using Helm, you can simply import and install in your environment, in your Kubernetes cluster. Or you can use Helm to build brand new packages also, using the Kubernetes manifest that you have. But we'll go over that in a bit. Helm can be used to manage the entire life cycle of charts, from creation to installation on the cluster, to upgrading the same package or the same chart that has been installed with a newer version. We could delete the charts that have been deployed in the cluster. We could inquire what the status is, and Helm keeps track of versioning as well. That means if we install multiple versions, later versions on top of a chart that has already been installed, it keeps track of that version as well. So a little background on Kubernetes. So we use Helm on top of Kubernetes to make working with Kubernetes easier. So with Kubernetes, the traditional way of deploying applications is using manifest files. These are basically YAML files composed according to a certain format. So this format is important. The structure of the file is important when we try to deploy the file using kubectl tool. It's kubectl being the client side tool that we use to interact with Kubernetes. When you try to deploy this, the composition of the file is checked. If there are any errors, we are not able to proceed past that point. So we have to be very careful to ensure that the file is correct, the structure is correct, and the values are correct. And so in order to deploy a Kubernetes application, we would need multiple YAML files belonging to, representing different resource types. In Kubernetes, there are different, a plethora of resource types for services, for endpoints, for secrets, for deployments, for pods, for different types of resources. We have to maintain different YAML files. So and how we deploy these YAML files is by using this command kubectl apply. -f, and then we would specify the name of the file. So this is what you see on the screen is a file for deployment, and you can see that it has properties, and we have specified values for them. For example, the Nginx here is the label for the app that we've used, and the replicas we've specified 3 here for this particular deployment. And yes, and the all important image specification you see towards the bottom, Nginx 179, that's the image that should be used to deploy this container. So each file needs to be executed one after the other. So as we covered here, a Kubernetes deployment will consist of multiples of these files representing each resource type, but each of those will usually need to be deployed one after the other. That means if there are 10 files, you have to run one, apply them one after the other, run this kubectl apply command one after the other, because you can't just because kubectl does not handle errors after execution. That means if the first file produces an error, you can't proceed beyond that. So we have to make sure that each file that we apply gets applied correctly before we're proceeding further. And values for these parameters are hard. For example, if replicas, the value of 3 for replicas property, that is hard-coded for this deployment. And if we need to deploy the same image, let's say we want to create another deployment of this Nginx 179 image, another container with this image, then we would need to manually edit the file, with a different replica number of replicas. Let's say we need 5 for that. Then we would need to manually edit this file and run the kubectl apply command again. So for complex deployments, we have that challenge. We have the challenge of maintaining these YAML files. If we need to modify a deployment, we will need to manually go and edit those files. We have that inconvenience to do it. Right, and you can see that, I mean, for this simple setup of 3 different services, you have at least 3 services for the database tier, 3 services for 3 resource types for the database tier, 3 resource types for the backend tier, and 2 for the front end tier. So in order to deploy this simple setup, we'd have to deal with at least 8 files. So Helm helps us abstract some of this complexity away by imposing a convention and introducing a templating system. Helm provides the ability to install applications with a single command. That means we don't need to just like we did before here. We don't need to have multiple files. We don't have to deal with multiple files. We don't have to apply them one after the other. I mean, if there are 20 or 30 resource types, 20, 30 services, we don't have to go in and manually apply them. Helm allows us to run a simple command on a single chart and have all of these files deployed. Yes, and the ability to have charts as dependencies of other charts, that also makes our life easier. We have the ability to build complex applications using previously built charts as their dependencies. So to represent each resource type, Helm has this concept of templates. A template is a default configuration that Helm creates by default, and we are able to customize it as we want, and we are able to define variables on them, and customize the parameters, the values that we pass for those variables as well. This helps the management of Kubernetes and deployments by allowing us to maintain a single chart but deploy them in different environments with different values. And charts can be versioned, and they can be stored in a chart repository. You can create a chart and you can share that with other users. That way, you can have a chart. We have public charts such as a chart museum that you can access over the internet, where you can download the popular charts from, like for example Nginx, or you can have you can host a private chart registry internally and place in them any charts that that you will be using within your organization, and share that across environments, or share that across teams. Yes, and Helm also maintains Helm also tracks the versions that are deployed for an application. In the context of Helm, a single deployment of an application is called a release. So if you can have one release, and then if a modification is made on the application, and you can deploy another release on top of that. So Helm keeps track of those releases, and if there is anything amiss, you can easily roll back to a previously known working version. And because of the ability to define variables within these templates that we'll just have a look at in a bit, Helm makes deployments highly configurable, and you can, in the as long as you have variables defined, and as long as you specify correct values for the appropriate variables, you can custom. All you have to do is pass the appropriate values in the install command itself. So all of these can be a particular application can be deployed with an entirely different set of values using a single command. And yes, and that allows us to deploy maintain a single chart with enough customization. You can deploy that in multiple environments, in dev, staging, and production, for example. So this is the Helm architecture. So you have chart files here. That means you could think of them as source files, and right. So Helm would create, get the source files, and it would create chart files. A Helm chart is, you could think of it as an archive, a TGZ archive, and once Helm packages these files into an archive, it can place them in the chart registry in storage, and it can import them from the storage, and then it can deploy that in the cluster. There's a special component, a server-side component of Helm that is running on the Kubernetes cluster, which is called Tiller. Tiller interacts with the Kubernetes API server and installs the charts and deletes releases as needed after receiving commands from the Helm client created by the user. And yeah, so that is it. And so below you could see how the Helm client connects to the Tiller server. So Helm client is a tool that we need to install on this outside of the cluster where the user is operating Helm, and using the Helm. I mean, once the you can install this tool using a common repository, a package manager. I mean, if you're working on Linux, you could use. If you're working on Debian, you could use apt and install that. And once that is done, you have access to this Helm command. Then, provided that you have already created a chart, you can simply running this command and specify the chart name and the namespace. You can contact the utility server that's running on the cluster and deploy the services. So Helm uses the same Kubernetes configuration as the kubectl. So Helm underneath it uses the same configuration. Right. So some key concepts of Helm are. The main one is chart. It's a bundle of information. It's you could say that it's the largest container of Helm that wraps everything. It's the biggest abstraction of Helm. And all the Kubernetes manifest files that we covered before, all of these, plethora of files, they would be Helm counterparts for representing these files would be wrapped in that in a chart. So a release, as I said, is a single deployment of a chart, and any running instance of a chart, and combined with a specific config as well. You could have a different release with a different combination. The Helm client is the command line client that we install on the side of the user that the user needs to that the user uses to interact with Helm and the cluster as well eventually. The service is the in-cluster component of Helm that is running within the Kubernetes cluster and interacts with the so it receives commands from the Helm client and interfaces with the Kubernetes API server. So it is you could say that it is the agent of Helm in the cluster that executes the commands that we issue using the Helm client. And Helm Hub and Chart Museum are public repositories where existing charts are available. And you could publish your own charts to this hub as well. And you could, if you need to deploy some common application, for example, Nginx, you could quickly pull it from one of these public charts, from one of these public repositories or registries. So we move to how to create charts. So a brand new Helm chart could be created simply using this command, Helm create. Nginx here is the chart name that we've specified, and you would then get a directory created with this file structure. And let's have a look at what each file is. So chart.yaml is a YAML file describing what the chart is. Usually that contains the chart name as well. And so what the information there are used by Helm to, for example, to name other services. So so that defines mainly the chart name and any version information also for the chart. Charts is a directory of any charts upon which this chart depends on. Basically, the list of dependent charts. This particular chart depends on. Templates is the main directory which contains all of your Kubernetes manifests. You could say that it's not Kubernetes manifests themselves. It's you could say that those are Helm templates representing each Kubernetes resource type that you want to create. For example, you see here that there's a deployment.yaml file, there's an ingress.yaml file, service.yaml, service account.yaml. Yeah, so right, you could add any number of services, any number of files here that you want. You could, here you'd see, for example, if you have multiple services as part of this application, you could rename this service to something my service 1 and have as many services as you want. Have as many files as you want to represent any other services that you have. And right, so templates nodes is a plain text file that gets printed after the successful deployment of the chart. Let's see that output in a bit after we install the chart. Right, so helpers.tpl is a place to store all of the template partials. They can be they can be reused in other templates. So tests contain any tests that we can define to validate the chart is working as expected. And the values.yaml file is the more important file that contains the that we can use to supply values for the variables that we define in these charts. For example, in deployment.yaml file, we can make the. This is where we would specify the name for the file. So we could make the name a variable, and we could supply the name or the number of replicas a variable, and we could supply the actual value for that in the values.yaml file, like we've done here. So by default, you would get a certain number of elements here, but you could customize the values.yaml file as you need. And this is such a customized file. You see that we've defined the what the repository name is to pull the image from, and the resources that should be allocated for the pod, the name of the secrets, the server ports that the containers should use, and anything that you want to do. Basically, these would not be available by default. These are the things that you can add as you want. So basically, you define the property and the value here, and then you go to the file, the template file, for example, the YAML file, and you mark up the location where you would hardcode that file. Just like here, you would replace this tree with a special syntax of two open curly braces and two closed curly braces, and within that you simply type values dot whatever the name that you define here. Values dot resources dot limits of CPU would be would result to 0.5. So just like that, you can customize the you can make the turn the hard-coded values into variables. So once that is done, once you created all of the files as you need, and once you supplied all of these values for these values to use in those variables in this values.yaml file, then you're ready to deploy the application in the cluster. You can simply run helm.install the chart name. Chart name would be this name that you get when once after you create the chart. Nginx is the name that has been given, so we would use Nginx here, and we would simply run this command and confirm that the output would confirm that the chart is successfully deployed. If there's anything, it would if there's any errors, that would be displayed here as well, in which case we would have to revisit the syntax of the chart and rectify. So this this is the notes section is the is what we covered here. It's a plain, so the content of this note section is what we see here, describing the next steps to take after this after this successful deployment. Yeah, so basically that is how we would use charts, but so we would simply create the chart. We would, in which case we would get a list of empty templates. We would customize them as we need according to our application, and we would define the values for the variables, any variables that we define as part of that customization in this YAML files, and then we simply run this command to install the application in the cluster. You don't have to sequentially apply each one of these one by one. Yeah, so that's about it for this presentation, and we quickly covered how to what Helm is, how what benefits it provides, and how to create a chart quickly and how to deploy it. I would like to answer any questions or any queries you might have on this. Okay, guys, I think we could wind down the call. Thank you for taking part today.